You ever just look up at the night sky and get this feeling that it's permanent? Timeless? We see the same constellations our ancestors did, just wheeling overhead in this perfect, predictable dance. Well, here's the wild part. That feeling of permanence, it's a complete illusion. Let's dig into why.
It's a great question, right? I mean, think about it. Our planet is spinning at about 1,000 miles an hour, and we're whipping around the sun at something like 67,000 miles per hour. So why on earth do constellations like Orion or the Big Dipper look exactly the same, night after night, year after year? Shouldn't they just be a giant blur?
Well, the short answer is distance. The stars are just so mind-bogglingly far away. It's kind of like watching an airplane high up in the sky. It seems to crawl along, right? But a car speeding past you on the highway seems way faster. It's the same idea. The stars are so distant that their movements are basically invisible to us over a single human lifetime. But that's just the simple answer, and it hides a much, much cooler truth. The night sky is not static at all. In fact, it's constantly changing in 3 huge, distinct ways that are happening right over our heads. So we're going to peel back each layer of this cosmic motion. Okay, so the first kind of motion isn't even about the stars themselves. It's about us. More specifically, it's all caused by our little planet's yearly trip around the sun. The effect is called parallax, and you can actually see it for yourself right now. Go on, hold your thumb out at arm's length. Now, close your left eye and line your thumb up with something in the background. Got it? Okay, now switch eyes. Close your right eye and open your left. See how your thumb just jumped against the background? That's parallax. Astronomers are doing the exact same thing, but their eyes are Earth in January and then Earth 6 months later in July. In theory, the whole process is brilliantly simple. An astronomer will measure a star's position against some super distant background galaxies. Then they just have to wait 6 months until the Earth is on the complete opposite side of the sun, and they measure it again. That teeny tiny angle of the apparent shift, that's the star's parallax. And here's the key takeaway. The closer a star is to us, the bigger that apparent shift will be. It's just like your thumb moving a lot more than the distant wall behind it. This tiny, almost unseeable wobble was the very first crack in the whole idea of fixed stars. And it's now a fundamental tool we use to measure how far away things are in the cosmos. In fact, this method is so critical it gave us a whole new way to measure distance, the parsec. The name is actually a dead giveaway to what it means. It's short for a parallax of 1 arcsecond. And an arcsecond, just so you know, is an insanely small angle. It's like trying to see the width of a pen tip from all the way across a football field. Tiny. Okay, let's move on to the second layer of motion. Parallax, remember, is an apparent shift caused by our movement. But the stars themselves? Oh yeah, they're moving too. They're hurtling through the galaxy at tens of kilometers every single second. See, the stars in our galaxy aren't just a static backdrop. Every single one is on its own orbital path around the galactic center. Over huge amounts of time, this causes the patterns we call constellations to stretch, warp, and eventually just dissolve completely. This true movement of the stars across our sky has a name: proper motion. It's the independent drift of each star. So while parallax is a yearly back-and-forth wobble, proper motion is a slow, one-way journey that plays out over millennia. And this slide right here really drives it home. Just look at the Big Dipper. 100,000 years ago, it looked more like a hook or a sickle. Today, we see that familiar ladle shape. But fast forward another 100,000 years, and those same stars will have drifted so far apart that the shape becomes this weird, flattened, unrecognizable line. It just goes to show you, our constellations are just temporary alignments of stars on their own separate cosmic road trips. So, the star with the fastest proper motion we can see from Earth is called Barnard's star. It's zipping across our sky at a blazing 10.25 arcseconds a year. Now, I know that number probably doesn't mean much by itself, so let's put it into perspective. At that speed, for Barnard's star to move a distance in our sky equal to just half the width of the full moon, it would take 180 years. That's how incredibly slow even the fastest stellar motion appears from where we're standing. All right, that brings us to our third and final motion. And this one is the slowest, the grandest, and in some ways, the most mind-bending. It's a motion of our entire planet. To even begin to grasp this next one, we have to think on a completely different timescale. We're talking about one full cycle that takes 26,000 years, a period of time that just dwarfs all of recorded human history. This motion is called precession. The best way to picture it is to think of a spinning top. You know how as it starts to slow down, it doesn't just fall over, its axis starts to wobble in a slow circle? Well, Earth does the exact same thing. The gravitational tugging from the sun and the moon on our planet's little bulge at the equator causes our axis to trace a giant circle in the sky over that 26,000-year period. And the most incredible consequence of this wobble is what happens to our North Star. Right now, Earth's axis points almost perfectly at Polaris. But as you can see, in about 13,000 years, halfway through the cycle, our axis will be pointing at a completely different star, the super bright and beautiful Vega. Our steadfast celestial anchor isn't permanent at all. And this has some real cultural connections too. This same wobble is what causes the position of the sun on the first day of spring to slowly drift backward through the constellations of the zodiac. For the last couple thousand years, it's been in Pisces, but now it's starting to move toward Aquarius. This is the real astronomical origin behind the dawning of the age of Aquarius. It's not just a song lyric. So let's put it all together. The night sky, which seems so fixed and eternal, is actually this incredible symphony of interwoven movements, all happening on scales of time and distance that are almost impossible for us to truly wrap our heads around. So you've got parallax, which is the apparent yearly wobble from our own orbit. You've got proper motion, which is the actual slow drift of the stars themselves through the galaxy. And then you've got precession, that massive 26,000-year wobble of Earth's entire axis. 3 different motions, all constantly changing what we see up there. So the next time you look up at the stars, just remember that what you're seeing isn't a static painting. It's a single frame in an epic slow-motion movie. The constellations might seem eternal to us, but if you could somehow watch that movie play out over 100,000 years, the sky would become so alien you might not even recognize the view from home.